come we will see combustion and flow diagnostics as an elective for 7th semester. This is in 3 credit course and this is in professional elective. So we will be having 3 hours per week. So from the title you can easily identify this course is going to speak about the diagnostics of combustion and flow behavior in various applications. The overview of the course, plus the specialty is about we are going to learn advanced diagnostic techniques, laser-based imaging, and some part of spectroscopy. Typical applications will be in aerospace propulsion and aerodynamics. People who are looking for aerospace R&D and energy sectors, they will benefit from this course. Some of the key topics which includes like study about light and its scattering, the traces which we use for imaging. So once we go into imaging, we need to discuss about lenses and camera. The typical physics which we are diagnosing is about flow on the flame. Then we discuss majorly about the high-speed imaging and quantification techniques like particle image velocimetry, laser Doppler velocimetry, planar laser-induced fluorescence, which are applied for flows and combustion, especially the velocimetry and visualization techniques. So typical course learning outcomes. These are like the candidate who enrolls into the course successfully completes, they'll be able to identify these dyes and how to use that in various types of flows, spectra from that. Then you'll be able to master about how to use an typical single lens reflection camera and about high speed cameras. You'll understand the basic principles behind this PIV and LDV and some part of shadowgraphy and PDPA techniques to apply for sprays. Then finally about some spectroscopy using fluorescence. This course module consists of 5 units. Basically, the first unit speaks about light spectrum and how this light scatters around traces, what are the dyes or traces that can be used for different visualization purposes. The unit 2 completely discusses about the imaging equipments, most probably the cameras and sensors and the techniques associated with it. As an accessory, we speak about light and lenses. Light means here the light source. Then the third unit typically it discusses about the flow diagnostics. It's purely the fluid flow diagnostics. And then the fourth unit it's about complete spray and atomization diagnostics. And fifth unit about flame diagnostics. We have various learning resources for this course. The typical recommended textbooks are Instrumentation and Measurements by Professor Radhakrishnan. Then for particle image velocimetry, we have a book by Professor Marcus Raphael. For atomization and sprays by Lefebvre. Then we have certain group of journal articles. I have mentioned a few journals here. One is Physics of Fluids, then Experiments in Fluids, Combustion and Flame, Journal of Visualization, Combustion Science and Technology. Typically, the skills that you acquire by doing mini project or cross project are like basically the laser safety protocols, how to set up PIV or PLIF experiments, how to do this flame imaging or flow imaging. The assessment strategy for this course is like we have typically continuous learning assessment. This is happening over the semester. And then we have a lifelong learning component, which will be like a small course project and then summative exam, typically your university exams. So majorly we will focus on application and then few percent the basic levels of Bloom's taxonomy. Who can choose this elective? It's like people who are interested in career opportunities. Like I want to work for R&D organizations, especially in flow and combustion domains. They have an interest in those areas. Those people can choose. And people who want to go into research, maybe probably preparing for ME or M.Tech, or maybe into PhD in propulsion, they can choose this. In general, if people have interest on knowing new techniques and want to have some exposure, demonstration and hands-on exposure to camera and combustion systems, those people also can choose this elective. So I am your instructor. I'm going to offer this course. You know my background, PhD in aerospace engineering. I have been working in combustion and droplets for past few years, and you can see my latest publications. This one is an example where we published this work in physics of fluids. This speaks about flame oscillations and image processing. We have a sample bunch of candles which are oscillating, and this is captured using a camera, and those images are completely converted into quantifiable data and mathematically processed it to show various plots that speaks about different physical behavior. This is a typical image, shows how a gel fuel combust. We can see the flame usually will be in a shape. This has some puffing behavior where this gel typically evaporates and make air pockets inside, and those air pockets rupture. It is like a bubble rupture, and because of the rupture the flame is distorted and it is moving towards the sides. This is one visualization where a droplet of fluid is trampolining on a heated surface. It has been done in our laboratory using a heater and a high-speed camera. The same effect when you have a non-Newtonian fluid, how it impacts on a heated surface and how it responds to the surface temperature. This work has not yet been published, so we can expect a publication soon from this work. These are the key publications in this domain. This is one of the latest publication. It speaks about the oscillatory candle flames. This is speaking about the ethanol gel combustion, and we had made a new study about the emulsion droplet bursting. In the study, we have recorded both visual phenomenon and also audio, how the droplet ruptures, and from the noise we will be able to correlate the peaks from the images acquired from visualization, and the correlated data has been reported. So you have a list of electives, and if you find this elective to be perfect for your career or your interest, you can go ahead, check the syllabus from your curriculum, and then you can choose your polling option. Ensure that you will be punctual to class and follow discipline to smoothly graduate. Thank you.